So in the last video we learned a little bit about angles, and today we're going to learn a little bit more about angles. There's several different types of angles, and today we're going to talk about several different pairs of angles. And you know, pairs means two. So there's several different ways that two angles can be attached together or appear together. And the first one is called adjacent angles. Okay, adjacent angles are two angles in the same plane with a common vertex and a common side, but no common interior points. And an example would be if we had angle A, B, C, and then we also had angle C, B, D. And so the way we would describe that is to say that angle A, B, C is adjacent to angle C, B, D. And you can see that two angles in the same plane with common vertex and a common side right there. No common interior points. So they don't have any interior points that are the same. There's no points inside of here. A non-example of this would be if you just had two angles that were next to each other like this. Just because they're next to each other doesn't mean that they're adjacent. Another example would be like a little lightning bolt thing. So you can see that they do have a common side, but they don't have the common vertex. And the next kind of angle pair that you need to learn is called a linear pair. A linear pair is a pair of adjacent angles, so it has to be adjacent angles like this, whose non-common sides, so this is going to be our focal point here, the non-common sides, are opposite rays. So this is a linear pair. So it's a pair of adjacent angles, so adjacent angles have a common vertex, they have a common side, but for a linear pair, the non-common sides, that's the red ones, are opposite rays, and together they form a line. So let's say this was angle 1 and angle 2. We would say that angle 1 and angle 2 form a linear pair. Again, some non-examples. If you had a set of angles like this, okay, they're adjacent angles. They have the common vertex, they have the common side, but their non-common sides here and here are not opposite rays. They don't make a line. And again, the lightning bolt kind of thing also doesn't work. So these are non-examples. The last angle pair that you need to learn are called vertical angles. And it's two non-adjacent angles, so it's not going to be angles like this that are next to each other. They're going to be non-adjacent. And it's formed by two intersecting lines. So this is the easiest kind to draw because you just draw one line and then you draw another line intersecting it. And now we have 1, 2, 3, 4 angles just by intersecting these two lines. And it says two non-adjacent angles that are formed by two intersecting lines. So non-adjacent would be angle 1 and angle 3, and also angle 2 and angle 4. And these are vertical angles. A non-example, close, right? It looks like, I mean, it sounds like vertical angles because they're both pointing up, but those are not vertical angles. And then all kinds of other stuff that you're going to see, not vertical angles, not vertical angles. So it's very important that you're able to identify adjacent angles, linear pairs, and vertical angles. All right, so real quickly, let's label each pair of angles as either adjacent, linear pair, and adjacent, vertical, or neither. So if we look at angle 8 and angle 5, well, you can see that angle 8 and angle 5 are formed by these two intersecting lines. They're not adjacent. so they are vertical. Angle 8 and angle 6. Well, angle 8 and angle 6 are formed right here. And that's two adjacent angles whose non-common sides form a line. So those are adjacent and they're a linear pair. And we look at angle 8 and angle 7. So here is angle 8. Here is angle 7. You might think they're vertical angles because they are connected like that, but they're not formed by two intersecting lines. They're formed by this line, and this one. So it took three, so those are nothing. These are neither. And the last one is angle 5 and angle 7. So angle 5 is right here. Angle 7 is right here. Common vertex, common side, adjacent angles. A couple more vocabulary words that you probably heard before, so we're going to go pretty quickly. Angles whose measure have the sum of 90 degrees, those are called complementary angles. Okay, so if one angle is 59 degrees, the complementary angle to that is 31 degrees, because 59 plus 31 is 90. Angles whose measures have a sum of 180 degrees are called supplementary. If this is 59 degrees, then the supplementary angle to this is 121 degrees, because 59 plus 121 equals 180 degrees. Now we get to something that you haven't heard. We're going to get to something called the linear pair theorem. A theorem is a rule or a fact or something that you can use to prove things once you have learned the theorem. So the linear pair theorem says if two angles form a linear pair, then the angles are. Now let's look at what the picture looks like. So let's say we have two angles and they form a linear pair. So it's going to look like this. So we have angle 1 and angle 2. Then the angles are. Out of the two words we just learned, hopefully you can see that the word is supplementary. And this is the linear pair theorem. It says that angle 1 and angle 2 have to add up to 180 degrees. If they form a linear pair, they have to be supplementary. The next one, the vertical angles theorem, says that vertical angles are always congruent. And so what that means is if we have vertical angles, no matter what the measurement of those angles are, that this angle and this angle will always be the same, and this angle and this angle will always be the same. So we can say that angle 1, if we mark them, I guess, let's say this is angle 1, 2, 3, 4. So angle 1 is congruent to angle 3. Angle 2 is congruent to angle 4. Move down and work a little example, a couple examples with these. So when we look at this picture, what do we see? We see two lines intersecting, and we see two non-adjacent angles. So these are vertical angles. And we just read, or just learned, from the vertical angles theorem that vertical angles are congruent. So that means that 3x is equal to 2x plus 16. And then here we go with our algebra, which is always going to be happening in this class. And we get x equals 16. Now, unlike some of the other examples we've done, this one said solve for x. So that's the answer. If it asked us to find the angles, we would just plug the 16 in and we'd find the angles. All right, example 3 says the measure of angle A is 2x degrees and the measure of angle B is 8x minus 20. Okay, we'll read a little more before we draw the picture though. If the angles are supplementary, find the measure of each angle. So supplementary means that they add up to 180 degrees. So this is saying that the measure of angle A plus the measure of angle B equals 180 degrees. So we're just going to substitute the measure of angle A for 2x. So 2x plus, and instead of angle B, we're going to put 8x minus 20. 8x minus 20 equals 180 degrees. So we combine like terms. 10x minus 20 equals 180. Add 20 to both sides. Get 10x equals 200. Getting down to the bottom there, so I'm going to bring it back up where you can see. 10x equals 200. Divide by 10, and I get that x equals 20. Now, this didn't ask me just to find x. This asked me to find the measure of angle A and the measure of angle B. So, the measure of angle A equals 2x, which is 2 times 20. So the measure of angle A equals 40 degrees. And the measure of angle B equals 8x minus 20. I'm running out of room here, so I'm going to skip a step. That's 160 minus 20, which is 140. And sure enough, 140 plus 40 is 180. So that's how we know we got it correct. All right, so that is it for angle pairs.